Good morning, YouTube. So this is my 10-minute challenge for today. I want to draw the other half of this bracket. So last video, I drew the bottom part of the bracket. And today I want to take that bottom part, modify it, and turn it into a top bracket. The other piece I want to do is the one that I used to have had the holes for one lamp. I want to make this into a device that can hold two lamps at the same time. So what we're going to do, we're going to start by flipping this bracket upside down. Remember to shift click in the inner ring in order to flip that steering wheel. And now I can rotate the entire design body. I'm going to type in 180 degrees. All right. Now, the next thing I want to do is I want to kind of look at the synchronous features that I have. I've got a box 1, a protrusion, a cutout, protrusion 2, sphere 1, and pattern. I can delete these different pieces right from the synchronous menu. And by doing that, I'm going to be able to simplify my design and really just take it back to a simple planar structure. All right, here we go. All right, so I still have the spheres, which form that nice rough surface, and I have my square and kind of weird wraparound shape for the post. Now, the next piece I want to do is I have a right angle metal rod, and I need to get it into my device. And since this is laying on the top of the table, what I'm going to do is just give myself a slot so I can get that rod in. So on the surface of the object, I'm drawing in a couple of extra lines, and I'm going to apply the tangent condition. And the trick in the tangent condition is whatever you select first is the part that moves. So here I've gone and I've drawn in 2 lines, applied the tangent condition, and now those lines are connected to the circle. The problem is that they're not breaking when I want to trim them. So I'm going to add in a circle. Same diameter as the original, 8 millimeters. And then I'm going to come along and use the trim command. So let's see here. There we go, trim. And that can just knock off the edges of those lines. The next step I'm going to do is select this middle region and project it negatively so that it cuts away that volume. And now I've got a nice 45-degree angle in there, and when I 3D print this, it should reproduce quite nicely. It also matches up right now very well to the alignment of my first piece, so the 2 pieces are matched. All right, next piece. I'm going to draw a square on the top of this object. And the reason I'm doing that is to give myself something to work with to put in the brackets for my lamp posts. They're fairly large, and I want to project this up, but still leave in the original hole feature. So, let's see if we can snap it in the corner here. All right, there we go. And select. Drag it up, and I'm going to choose a distance of 35 millimeters, just because when I measured the original clamp, it was 45 millimeters high, and I thought, okay, I can make that work. So there we go. We have our original portion, and a little bit of a box on top. I'm going to add in an 8 millimeter diameter hole, add a right angle to the original hole, just so that I can stick my bent rod in there. So here we go, collect on the center, being kind of finicky right now, and drag it out, 8 millimeters. All right, so type in 8. Now what I want to do is I want to select that surface, there we go, and drag it all the way to the other end. But right now this is a positive, so I need to change it to a negative, so it actually cuts out a hole. This is doing a Boolean operation with the geometry. There we go. That looks perfect. All right, next I want to have 2 centers for my holes for the lamp posts. So I've drawn them 11 millimeters from the center, and that's just because the posts themselves are 13 millimeters, that rod is 8 millimeters. It just seemed like a nice combination. So select the 2 surfaces, drag them down. I'm going to choose 40 millimeters. It's almost the full height of the object. I probably could have gone something like even 38 millimeters and still been fine. All right. The last kind of feature I want to do is having a big box on my desk. Probably going to crash into it, hurt myself or whatever. So I'm just going to round the edges. After I 3D printed it, I forgot, don't round edges when 3D printing. They just don't work well with the way that a 3D printer will slice and then actually extrude the material when you're rounding or coming up from the base plate. So you can round other edges that aren't on the base plate, but the base plate ones don't work very well. All right, so here I had an interesting problem, just a little bit of extra geometry. So I needed to knock off 5 millimeters on both of these. Again, just did that to kind of give things a little softer finish. But this particular corner here had extra features on the geometry, made it a little hard to work with. But there we go, 5 millimeters and 5 millimeters. I could have chosen something simpler or smaller, but not really necessary. And that's my object. All right, so take a quick look around. Everything looks good. Oh, sorry. Wanted to just round off the edges as well. Just give it a nice round feature all the way around. And these are actually the ones that caused me problems when I 3D printed it. So we'll grab that one. We'll grab this one over here. Now, just as a little thought, you do want radius curvatures when you're transitioning from one plane to another, because right angle corners will fracture and cause stress locations, some places where things break. So I'm kind of happy with all this rounding. All right. All right, 3D print. Looks good. Export it. Open it up in Prusa Slicer. Just drag and drop the model in. I am going to make 3 copies this time because I want to see how the different orientations will slice. So there's 1, 2, and 3. And just hit auto arrange in a moment. After I'm going to change the orientation of the objects. So we've got our original that's still orange, we've got a rotated object that's green, and the other one, we're going to change the rotation of that as well. So 3 different rotations, arrange it, move them around. And slice it up. So first thing you'll see is the yellow is the outer perimeter, the reds is the top solid infill, and I'm going to go and scroll all the way through the material from 0 all the way up. Now, we're going to look at each of the different bodies separately, and I'm going to have a problem with the first one almost instantly. So what I see here is I have nice little dots. Those might work okay, or they might lead to everything falling off the print bed. But right around the third or fourth layer, I have a large unsupported geometry, and that's going to cause everything in the print job to just fail. It's going to start going all over the place. It's going to just create a giant mess. So in my second model, what I see here is a nice smooth transitions between different surfaces. These yellow dots are popping in and out. That's okay. I expect that this is going to print pretty much okay. And quickly looking at the third orientation. So this is with the circles on its side. Again, not seeing anything really outrageous. Nice continuous flow in the geometry. And knobs on the bottom will print nicely. So this is also a good candidate for 3D printing. One thing to recall is that the Z direction for your 3D print model is the weakest direction. So I think this is probably my best choice. The second and third model both look reasonable. All right. So going back to full view, delete, delete. I'm left with this one, and I'm going to try and print this. In practice, what I found was the rounding on the bottom edges caused some problems, but it was pretty minor. Thank you for watching.